So, quick introduction for those who don't know me, which are probably not very many out there. I've been with the Samba team for more than 20 years now. I've been doing data storage for quite a long time. Actually, I started with SMB in the 80s, which is kind of a long time ago. I've done some writing, book on SMB. I actually wrote the specs, me and Jose Rivera. We wrote the specifications for SMB1 for Microsoft. Hello, Tom. Tom inherited that doc. I'm sure he's already buried it in the backyard somewhere. Anyway, usual stuff. I'm not really connected with any corporate entity at the moment, but I do know that my dog does climb up on the bed at night and whisper in my ear. It gives me all sorts of wonderful ideas of things to do the next morning, like buy kibble. Me in my natural habitat. So just an acknowledgement, some of what I'm doing here, there are other people working on all sorts of amazing things within the Samba team and outside the Samba team. I was very impressed with the SMB CMP work. I watched the previous presentation. A lot of stuff going on. Kudos to everybody. Whatever I'm doing here, it's not intended to be a competition. I'm just following my instincts. And my instincts have led me here. So that's my diagram of a SmartNIC. You can tell that it's a SmartNIC because of all the detail I put into the diagram. So I'll be using that through the presentation. If you're not familiar with SmartNICs, they're really kind of an interesting idea. They've been around for quite a while if you are familiar with what are known as tow cards or TCP offload engine cards, which eventually became SCSI controllers, iSCSI controllers. So that there's the iSCSI protocol and then there's TCP under that, all on the card, so that from the point of view of the host computer, it just looks like another iSCSI, it looks like a regular SCSI card. But the modern SmartNICs, which have just recently become a very big thing, companies buying other companies to get hold of this technology, lots of vendors coming out with them. Mellanox, Intel, Chelsio, Xilinx, etc. Lots of cards coming out over the past few months. These cards, network interconnectivity and a bus, there's processing power and memory. Sort of like a Raspberry Pi. I like to think of it as like a Raspberry Pi on steroids with a jet engine and a sugar buzz. A lot of power here. And the network capabilities now go beyond TCP and iSCSI. They now cover RDMA. Hopefully they'll cover QUIC. The only reason I can think of not to, have something like NBT in there is that NBT is old. And a lot of people say it's dead. I don't know if it really is or not. We'll see. I've already heard NetBIOS mentioned once in one of the presentations yesterday. So, in the advertising for these cards and in the press releases, they keep saying that storage is the killer app for SmartNICs. So here I am seeing all this press on these things, and the press is all saying storage is the killer app. Well, where does my mind go, right? What can I do with that? What does that mean to me? That's an interesting kind of a question, I think. Something I'm going to let you, contemplate for a while. But consider this, during Ralph's presentation yesterday, he was talking about, the packet handling layer in Samba. And I'm looking at these things and thinking, here's a bump. Let's say it's on a server, could be on a client, but let's say it's on a server. The client connects over the network, gets to this bump before it gets into the computer itself. What does this bump do for us? It's a bump in the network connectivity path. So obviously the thought comes to mind, what about SMB offload? We could do marshalling and unmarshalling of packets, packing and unpacking. compression and decompression. These are naturals for these cards, and there are, that's built into the SMB protocol. Host provided state means, if the host were able to send a message to the card and say, hey, here's some information you need, which it can, then you can suddenly do the encryption piece, the signing and sealing, because you can pass the keys across. And then we get to the next thing, and that's, RDMA is one of the protocols that we could support here. RDMA puts the important data right into memory on the host. Well, if you have a SmartNIC that's doing the parsing and packing, it can put information directly into memory, whether it's over RDMA or QUIC or some other protocol. So there's a lot of zero copy opportunity there. And the other thing I was thinking was, why waste time on SMB1 when SMB1 is really gone? We can focus on SMB2 and SMB3, which are essentially the same protocol. So the question then is, okay, let's look at that picture. How does that fit into our overall SMB2, SMB3 implementation, right? And I came up with this very sketchy stack. It's not a very formal stack, but obviously at the bottom layer, we've got our transports in the wire format. Then there's a syntactic layer that we can handle with the offload engine. We want to convert wire format to an in-memory layout that we can use at the host. Then I have what I call the fuzzy layer, and I'll talk about that a little more. This is where things get a little nebulous as far as how it all works. And then at the top, there's our semantic layer. And the semantic layer at the top, this is what, again, I think it was Ralph, maybe it was somebody else in one of the presentations yesterday, was mentioning something we all know very well on the Samba team, and that is that most of what Samba does is semantics, translating semantics, handling semantics, dealing with behaviors that are expected versus the behaviors available on the local machine. POSIX to Windows to POSIX to Windows, back and forth. And then, of course, if you have a particular implementation, there was a presentation covering GPFS, and that has its own behaviors, you want to adapt to those. So we have to manage the Windows file system semantics, take care of the Windows locking, identity, OS2 EAs, all that kind of stuff. We have to manage local file system interface, the POSIX layer. We have to synchronize with other access, local access, NFS access, object storage access, perhaps. A lot of vendors I've worked with are trying to, they really want to solve this. How do we make sure that it works with, local connections and object store and NFS all at once? And there's a lot of other metadata management, Windows attributes, the ACLs, access controls in general. And then, of course, we have a long history on the Samba team. We have a long history of supporting clusters, which is a more complicated environment that we have to be able to manage. The semantic layer handles that. And fortunately, it's not part of what I see going into the offload engine, although you do have to keep in mind all those things the semantic layer is doing for you, so that the API between the semantic layer going through the fuzzy layer down to the offload engine can be useful up and down the stack. You have a lot of things transiting that stack. In theory, if that API is useful, you could run different implementations on top of it, and even run different implementations in parallel on the same host if you wanted to do, for example, testing, or if you had a specific implementation for a specific file system that needed to run in parallel with everything else you're doing. So the fuzzy layer is where things get interesting. How do you connect your semantic and your syntactic layers together? it's where you're going to handle this shared state, the information you have to push down to a card, for example, like the encryption keys. You might have to keep track of sessions, tree connects. You certainly have to keep track of connection state, whether it's whatever kind of connection state you have. You may not know that the underlying protocol is TCP or QUIC. You may need to know only that you have a connection. So you need to be able to communicate with the NIC as well, so you can tell it what to do and get answers back from it when it's done them. Again, I focus on the idea of coming up with a rational, well-documented API. It needs a couple of layers, because one of the things it needs is a low-level interface that you can stack. So if you think of Samba's VFS layer and the ability to stack different things on top of each other, let's say, for example, that you had a implementation that covered everything from SMB2, SMB3, top level being current SMB311. And then a couple years down the line, Microsoft releases SMB 3.7.1. Now you need to be able to work with that and test that. And you may not be willing to wait for your NIC vendor to come up with the 3.7.1 update for the firmware on the card. So can you stack? Can you write a layer in between that is going to accept the data coming off the card, do a little more parsing to it, and then pass it back up the rest of the fuzzy layer stack so that the semantic layer can work with the results? That's one of the questions I'm trying to figure out. One of the obvious answers there would be, wouldn't it be cool if those NICs would allow for an open source loadable module that we could add on our own, and have an open source community building those modules that would then stack on the card. So the fuzzy layer becomes a combination of a device driver, a library, maybe a toolkit, parts and pieces that work together to give you control over what's going on that card for your SMB stack in particular. And then, of course, the whole reason I'm thinking of all this, the whole reason I'm approaching this at all, is that the SmartNICs are there. And it would be really interesting, and this goes back to our keynote, I think it would be interesting to be able to, offload some of these features, the encryption and compression, just handle the message syntax errors there on the card. The upper layer never has to see that. Possibly, can we run multi-channel on the card itself? And what we're passing up to the upper layers is just the stream of already unpacked and cleaned up messages that are ready to be processed. Obviously, we can support multiple transports. How much of those details can we hide from the upper levels of the stack? I just want to make sure that Oscar is going to let me know if anybody wants to stop me. But here I am already at yet another project. Okay, this is where I start talking about what I'm really up to, and this is where I'm going to switch screens a little bit. I have a project called Zambezi that I've set up. It's on GitLab. It's LGPL at present. The licensing may change, and I'll explain why. When I say change, there might be additional licenses added, but I'll explain why in a little bit. I'm only putting up code when it's ready, although I've got a few pieces up there. I've got a lot more that I'm working on right now. And typical of me, for those who know me, it is excessively documented code. So here we go. I hope everybody can see this. Here we are.
Yes, but we have also a question.
Very good. let's go.
Volker Lendeke asks, have you thought about doing the API design in user space with an IPC mechanism?
Actually, yeah. So there are two things about the API design. One is that, first of all, the reason I want to do this presentation now is to get that kind of input, feedback, etc. And what I have on a later slide is that I've already talked to some of our common friends at the SNIA about doing a standardization process. And the Zambezi implementation that I'm providing here is intended to be a library that will become a reference implementation so that we can build that API and then provide it to vendors, provide this code to vendors as a reference to work against, right? And then, of course, we would be able to port to this, or once the API is standardized, the same upper levels would be able to switch to different devices, different vendor cards, or kernel implementations, or whatever else you might have in mind that can use that same API. Does that answer the question? I hope so. All right. Here's my project page. All right. And it gives an explanation, particularly the licensing philosophy. One of the things about this, of course, I am known for being verbose. Jeremy Allison once said, hi, Jeremy. Jeremy once said that I don't write code, I write novels. And unfortunately, I take that as a compliment. So here's the Doxygen. It's quite a bit of it already, although most of it is, when I say quite a bit, it's because I'm verbose more than anything. But we already have some code. Yeah, you'll notice that there is a small NBT implementation. I have one from years ago that I wrote and stuffed away and never did much with, so I figured I'd revive that and just throw it in. As I clean it up, I'll be adding it here as it makes sense, but I'm focusing more on the SMB piece. And right now, this is the low-level piece. This is the part that does the parsing and packing of packets. Once we have that together, then the goal is to write the upper-level piece that would be accessible by through the fuzzy layer by the semantic engine. All right, and again, I go back to Ralph's talk yesterday about the pathway of a packet through the Samba stack. There are plenty of ways to hook this in available to us. All right, so the next thing I'll point out is that there is also a wiki available that has a few pages already written up. And I'm working on, whenever an idea hits me that I need to describe, I work on filling that in as well. So let's go back to our presentation. There we are. So at the low level, I'm looking at, the fact that SMB2, SMB3, same protocol, has 19 commands. And 19 commands is just about a quarter of the number that SMB1 had. So it seems, at least at first glance, to be a much more consumable measure. I have, for my own sake, just to make it easy for me to think this through, divided these up into these 6 generic categories. They're not for real categories. They're just what I've divided them up so I can take them in bite-sized chunks. What I find, and I've done the math in a couple ways. Let's see if I have that written down here. Yep. Okay, that's, if you have 19, then in theory you've got a request response for everything. That's 38 messages, except that cancel has no response, so that's only 37. But then you add 3 for the op lock break, And well, that really depends on how you categorize it, because there are op walk breaks, and so there are least responses, and there are op walk responses, all sorts of combinations there. I wind up with 41, and then when you get here, very many of them, 9 messages overall, are really what I call a base message, but that is essentially a null message. You get 2 bytes that say, hey, this message is 4 bytes, and then the other 2 bytes are zeros. So it's an empty message, signifying basically nothing. All the important information is in the header, and I've already got a parser and a packer for the header. So basically, these are essentially done. They need a little bit of documentation and framework around them, but otherwise, these are done. So I'm working on a variety of other messages in the code. It's nice to have these out of the way. But let's look at one of those. The SMB echo, which everybody would think is a simple message. It's actually a little more complicated than that. It's something you have to think about. SMB1 had an echo, and it had some interesting features. First of all, you could call it after and negotiate. You didn't have to have a session created. You didn't have to authenticate. With SMB2, you have to authenticate before you can send an echo, and this is good. It's a protection. Also, SMB1 had a payload. There is no payload for SMB2. SMB1 had an interesting feature. You could say, here's a message, here's an echo request, send me back 5 responses. And per the protocol, you should get 5 echo responses back. Now, many implementations disabled that or didn't implement it at all, but it was an interesting way of creating a denial of service attack. And so, we're glad it's gone. So that's been removed. So that simplifies the echo in SMB2. But now we get to the next question, and that is, should it go only as far as the NIC? Once the NIC receives the echo, can it say, oh, yeah, I got the echo, I'll just respond? Or does the syntax layer have to verify that the semantic layer is still up and running and serving the session that the echo was received on? These are the kind of things you have to make sure you've covered. And yeah, I would say you have to do that checking. You have to know that the session is still alive. So you have to go all the way up the stack to verify that. And that's the kind of thing I was saying before. You have to be aware of the semantic layer when you're writing this piece. That's why. This is a very simple command, but you have to know that it's got to go all the way up the stack and back. And the other thing I have on this is, okay, where else might this stack, once we have it put together, once we've got it considered, where else might it be useful? A couple of weeks ago, I was sitting in on a presentation on an open source, mostly open source, network as a service system that can be loaded into a Linux-based switch. So you have a Ethernet switch with lots of different ports, 10 gig ports, 1 gig ports, possibly other things like RDMA capabilities built into this. It's running Linux, and you have a network as a service. You can define subnets. You can do layer 2, layer 3 configurations all in this. And it occurred to me, if you had an SMB low-level engine on there, you could inspect packets, you could make decisions on packets, you could convert multi-channel, incoming multi-channel from a variety of things into, in one end, out the other, to different servers. There are a variety of things you could do. You could do WAN acceleration. You could do, I have here, aggregators of different sorts. If you know that your SMB server in the back is a clustered SMB server, you can do load balancing. For the modern 2020 work-at-home environment that we're living in these days, what could you do in terms of facilitating remote access? I have spent time working with the Windows branch cache technology. I've done a little work on that. Work at home, maybe could find, there might be ways to accelerate work at home if you started, implementing some of these pieces. Small office, home office type acceleration. So what kind of thing could we do there is one of the questions I've got open still, and I want to consider as I move forward. So my goals with this project, number one, is to get it done. I've got a few projects in my history that I've done fairly well on. If you remember JSIFs, that went on to quite a nice future, and we had quite some success with that. But I've started a couple of other things that we haven't gotten done yet, so I'm looking forward to getting this one done. And I'm making good progress, especially these days. Work with the SNIA. I've already, as I said, approached the SNIA on what we could do with this, and I obviously am approaching people on this presentation to see what kind of input you want to have on that. Eventually, the idea is to fork the reference implementation, Zambezi, and fork it under an additional license so that it could be used as a reference implementation. The SNIA usually has some requirements there. And then I reached out to a couple of SmartNIC vendors already to say, hey, I'm working on this. What's your interest? I've gotten some good interest. One of the companies is in Germany. That's a nice thing. I've gotten some good interest so far, but there's been some turmoil in the industry lately, and so we've got to get back to discussing it, and then find those new and interesting uses for what's being developed here. Now, I've kind of rushed through this. It's a lot more fun when I'm face-to-face with people and people can interrupt me live. That's what I have on the presentation. If there are any questions, I'd love to have a little discussion on where this is and where it can go, and how to make sure that it does what everybody else is looking for it to do. So I'm going to switch back now to the Zoom session. And I have a Q&A. Oh, there we are. Okay, does Zambezi have a special meaning? I like the question. Thank you, Steve. Actually, on the GitLab page at the bottom, it does explain that Zambezi is the name of a river in Africa. I also bring up the possibility that it is the name of a long-forgotten 12th century Antarctic poet. That's less likely. No, the project just needed a name. And I was rewatching old Monty Python episode, and Zambezi came up in the discussion. So that's the name I chose. But it needed a name, so I chose it. So Tom had asked about block APIs. What else? I'm looking more along the lines of a simplified SMB related extension API. When something like an echo comes in, all the server really has to do is say, yep, right? So that the at the offload engine layer, it's just got to send the message up in the queue that says you got an echo, yes or no, return true or false, or don't return. If you don't return, now it's the offload engine that has to make the decision. Okay, there's a timeout. The timeout's got to be there in the offload engine. You don't get a response back, you shut down the connection, right? Because the offload engine is actually managing the connection. Let's say it's a TCP connection. It's the offload engine that's managing that. It has to know how to shut it down so that the other end of the connection has got the information that the connection is really dead. And of course, if the offload engine is the part that dies, well, then that has to work correctly as well. At least that has to work the same way as if a machine were to go down. I'll bring up something that was also brought up in one of the presentations yesterday, and that is Samba's multi-process model. I think this architecture needs to support that. If the offload engine itself can be multi-threaded or in some way so that if one connection goes down, it doesn't bring other things down. If something fails, it doesn't bring everything down. Multi-process, multi-thread, depending on the architecture of the card, that is a bonus. But we are separating that from the upper level where you need to have user syntax, user environment. So in the upper levels in Samba, we keep separate user processes so that we can maintain security. At this lower level, you're not dealing as much with user context. And in fact, you don't really care. But our API needs to be able to work with that upper layer where there are different user contexts. And that goes back to some of the struggles we've had with our RDMA implementations. I know that that Metsu was working on kernel version. Richard Sharp has been working on things, but because of the semantics of the RDMA connection per the specifications, that's been a bit of a challenge. Hopefully, we would be able to resolve that challenge in this stack. Oh, we've got two more questions. Any thoughts of difficulty of offloading a client sending requests versus yes? So this is from Steve. Today on client, we only offload reads and only offload to threads, not to hardware. RDMA in some sense offloads. So yes, Steve, I've been thinking about this, but I'm glad you brought it up because I am thinking about it, and therefore, I have a number of questions. I very much am thinking about your work when I think of this development. I would like to make sure that this works with the CIFS kernel module, the SMB kernel module. I think we need to think of it as, and so yeah, this is one of the reasons I need to present this is so that we have this discussion. I need the questions that you would be able to raise. Going on here quickly, Tom Talpe, front-end multiplexer does sound interesting if specialized. Yeah, but at the same time, what if we have multiple NICs in the box? So again, that fuzzy layer, we have to be able to take the mux demux on multiple cards or coming straight through a card that isn't doing mux demux and bring it up as well. This is why the whole thing has to be stackable. Is that what if we have multiple cards? We have to be able to mux and demux at a higher level as well. So that's a really good point as well, Tom. Thank you. And yes, Steve, reminds you of the dark ages in the distant past where OS2 processed requests, as did Novell, at interrupt time as much as possible, and then handed it off to the thread waiting on the request. OS2 was kind of an offload engine at front end, of a mainframe and pre-processing SMB requests coming into the OS2 front end, and then sending them up to the mainframe only if the front end OS2 processor couldn't handle it. Bingo, right? This is one of those, what comes around goes around, what goes around comes around. And I'll go back to Volkers in a second. Volkers, another good point. So Steve, you're absolutely right again. This is one of those things where we go back and look at how things were done 20 years ago, 40, 30 years ago, and look at whether or not they're applicable today. We have wonderful opportunities here, but at the same time, yes, this reflects very much how we used to do things. Remember the original SMB system running on the PC network system, the NetBIOS the NetBIOS aware LAN cards, the PC, the cited cards, did a lot of handling on the card, and then called an interrupt to pass the NetBIOS message up the stack for DOS to handle. Simplified, but that's exactly what happened. So yes, you're right. Volker says, offloading SMB read and write into the kernel without involving user space SMB would also be interesting. Absolutely right. So I think it's fascinating. People are seeing some of this. That's great. This is where I've been coming from, and the fact that it's an obvious thing to see once you've got the idea. That's great. And yes, so I'm coming up with the first level reference implementation. And that's nothing compared to what I think we can do with it once we have that in place. I'm hacking together the first version maybe, and then I think what people can do with this down the road could be much more interesting. Hey Tom, well, we used to do things this way because processor and memory were so limited. Things are different today. That's true too, but at the same time, and again going back to our keynote, things are different today, and yet we still have this need. We could, let's say we have lots of clients out, and they go into an aggregator that can do the RDMA, that can do NVMe capability, etc. Now you have a way to accelerate from the network as a whole into the storage cluster you have at the back end, by combining these multiple streams into something faster. It might be a way to improve things. Again, load balancing. Again, if you have multiple of these that you can switch between, one goes down, you can run on the other. You can front end a lot of this to perhaps get even to proxy to fast storage. Be way to do things. This I don't know yet.
Chris, I don't know if you hear me, but we can't understand you. So oh, he's gone.
Video.
Hello.
Okay. Hello, it's me. How far did I?
Yeah.
We here?
Yeah, I hear.
Okay, one more comment here. Chat. Are we back?
Yes, maybe.
Where did I leave off? Where did I stop? Q&A 3. Okay. Okay. So I have a question. Can you hear me, Oscar? Can you tell me how far did I get in answering the questions before my internet dropped?
You were at the third question.
Okay, so I was just thanking Tom for his question, and saying that we have opportunities, though, due to the fact that people are still pushing for more and more speed out of these types of systems. I don't know how much of that answer got through, but I think it's worth exploring, and I'm glad to be. I'm glad of the interest I'm seeing coming back in the questions. It's really positive feedback for me, and I hope to open this up so other people can keep poking me and maybe take on some of this if you're interested. And if there are any more questions, please let me know. We still online?
Yeah.
Okay, good. All right. Well, if there are no more questions, comments, or other things going on, I'm very grateful to the feedback I got on this. The questions and challenges are exactly what I was hoping for, and that because that indicates interest, and that excites me.